In Java, streams are a powerful way to build, process, and summarize collections. In this video, I want to give you a quick overview of streams and then tell you why you want to learn more about them. Streams can be more powerful than loops because a stream has lazy evaluation and can be parallelized. That means that we can play with really huge data sets. In order to understand the code examples, you're going to need to understand lambda expressions. Click above if you need a video on those. A stream is a collection of data and a pipeline for how it should be processed. The pipeline starts by creating the stream. This may take some existing data, or it might build the data on the fly. Once the stream is created, we send it through a sequence of intermediate operations. These might compute new things from the current data, filter the data, or manipulate the data in other ways. Each intermediate operation results in a new set of data that flows into the next stage of the pipeline. The last operation in the pipeline is a terminal operation. These either gather the sequence of things coming out of the pipeline or summarize it in some way. This video tries to answer the question, why bother with streams? What do they give me that I can't do with a loop? I'll build other videos with the details about how you create and use them. One of the great benefits of a stream is that the intermediate operations are lazy. They aren't executed until they're needed. As an example, look at this code. It's converting a list of integers into a stream and then filtering them. The filter method requires a lambda expression that returns a Boolean, and ours is checking that the integer is odd. I've inserted a print statement in here so that we can see when it happens. So at this point, filtered is a variable that contains that stream. Then we use the for each terminal operator to print out what is in that stream. Look at that output. It printed that the stream was created before we saw any of the prints from the filtering. The JVM didn't execute anything in that stream until we used that terminal operator. That's what we mean by lazy evaluation. With this example, the magic of lazy evaluation isn't really important. However, with this example, I've created an infinite stream of integers. And yes, infinite. It'll overflow and wrap around forever. Then I filtered it the same way we filtered it before. And then I added a limit call to say I only want the first 5 that you see. Now, when I run it, I get the first 5 odd numbers, and the numbers above that were never generated by the iterate call. I think of it like this. The terminal operation is pulling data from the last step in the pipeline. When that step needs data, it pulls it from the one before, and so on. That way, we only process the data that the terminal operation needs. That's a pretty powerful way to deal with a very large data set. Now, just for clarity, I've added a lot of stuff to those stream examples to demonstrate the laziness. If we clean that up, using streams instead of loops to do these things actually creates pretty clean code too. Look how simple each of these becomes. And I don't even have to store the stream in a variable at all. Another benefit of streams is that they can be parallelized. While there are a lot of subtleties to this, I'll do some simple examples to show you what's possible. Then I need to make a whole video just about that. To show how parallelism works, let's make a stream and print it out. I'm making it print the thread that is printing it too. If we don't parallelize it, the numbers come out in order and they all come from the main thread. We can parallelize that by using parallel stream when we convert the list to a stream. Now, each number gets its own thread, and they come out in random order. That shows one important point about parallelized streams. We can no longer control the order of the operations. We can combine this with intermediate operations, but then we have to be a little bit more careful. Some intermediate operations are stateless, which means that they don't remember anything from one element of the stream to the next. Those operations can be safely used in a parallelized stream. Ones that are stateful would be risky to parallelize because we can't control the order in which things happen. An example of a stateless intermediate operator would be our filter operator. we can parallelize the filters that we were using before to get only the odd numbers. And again, each gets its own thread. The threads that are used by default are the fork join pool threads in the fork join framework in java.util.current. The number of these is limited by the number of threads your processor can support. My processor is an i9 that supports 32 processes. So let's make an infinite stream and have it print out the first 40 odd numbers. Here's the output. You can see that it reused a few of the threads. There are a lot more details about how you parallelize threads. I'm hoping that this was enough to get you started with streams and to motivate you to learn more. I'll build more videos to show you more ways to create streams, process them with intermediate operations, and get results out of them with other terminal operations. And then more details about parallelism.